Students, let us try to solve one or two numerical problems based upon the graph. So first problem is that velocity time graph of an object moving along a straight line is given below. From this graph we had to find out the distance covered by the object in between. First part, time t equal to 0 to 5 seconds, and second from time t equal to 0 to 10 seconds. Very simple. We know that this is a velocity time graph, and from the velocity time graph if we find out the area, then we get the displacement. Okay, that means we have to just find out the area of the graph. So in the first part, when time is given 0 to time t equal to 5 seconds, that means we have to find out the area under the graph O, A, B and D, which is nothing but the trapezium. So area under OABD is equal to half into sum of parallel sides. Parallel sides are AB and OD multiplied by the perpendicular distance connecting the two sides, which is BD. If we substitute the values, half into A to B, you can see that at A point time is 2 seconds, at B time is 5 seconds. So in between A to B, what will be the time? It will be 5 minus 2 multiplied by BD plus OD. OD is time from point O to D, which is equal to 5 seconds, multiplied by BD. BD is nothing but velocity of the body, and BD height is equal to 20 meter per second. So we get half into 3 plus 5 into 20. 2 times are 20, which is equal to 3 plus 5, 8 into 10, which is equal to 80 meter. This will be our first answer. Similarly, we can find the second, from time t equal to 0 to time t equal to 10 seconds. Over here, we are finding the complete area OABC. So in this case, you can see that we have to find out the complete area under the graph. So 0 to 10 seconds. We have already determined this much area right from point O to A to B to D. So this area is already available to us, which is giving us the distance covered from 0 to 5 seconds. This is 80 meter. So what we need to do, we just need to find out this much area between point B and C, that is in the right angle triangle BDC. So area under OABC is equal to area under OABD plus area of the triangle BD and C, which is equal to 80 plus what will be the area of the right angle triangle BDC? It will be half into base into height, which will be equal to 80 plus half into DC is at point D time is 5 seconds, at C it is 10 seconds. So time interval from D to C 10 minus 5, 5 into height BD is again 20. 2 tens are 20, 10 into 5, 50. So it will be 80 plus 50, which is equal to 130 meter. This is our second and final answer. Our second question. A motor car starts from rest, moves with the uniform acceleration and attains a velocity of 8 meter per second in 8 seconds. It then moves with uniform velocity and is finally brought to rest in 32 meter under uniform retardation. Total distance covered by the car is 464 meter. We have to find out the acceleration in the first part, retardation in the last part, as well as the total time taken, that is total time motion of the body. In this case, we are not given. In this case, we are not given the graph, but we have to plot the graph available information. So, because they are talking about the acceleration, uniform acceleration, this means it is a velocity time graph. So this graph will look like something this. Here we have the time on the x-axis, velocity on the y-axis. So we divide into the different sets and we will draw the graph. First it says that it is starting from rest, means initial velocity is 0 and it moves with uniform acceleration, constant acceleration. It means equal increase in velocity in equal interval of time. That is a graph, straight line parallel to time axis. So first section of the graph is from point O to A, corresponding to which the velocity is 8 meter per second. Velocity in meter per second, time in seconds. It then moves with constant velocity, uniform velocity. So for a certain time, it moves with the constant velocity. So speed is constant, velocity is constant from A to B, and then it is brought to rest under uniform retardation, means graph with negative slope. So this is our graph. So if we draw perpendicular from point A and B, this is time t1, this is time t2. Okay, let this is point D, this is point E. So from O to E, it moves in the time interval with the uniform velocity, uniform acceleration, t1 to t2. In this interval, it moves with the uniform velocity, and from t2 to final point t3 time interval, it is brought to rest under uniform retardation. Now, what information is available to us? We had to solve this purely with the graphical method. Also given to us that it is moving 32 meter when it is brought to rest. That means from T2 to T3 time interval, distance covered is 32 meter. Total distance covered is 464 meter. T1 time is 8 second. It is given to us. So first we find the area under the velocity time graph. So area of triangle OEA, it will give us the displacement covered in this time interval. It will be half into OE into AE, which will be equal to half into time 8 second, velocity also 8, which is equal to 32 meter. That means body is covering 32 meter in this time. Okay, and it is also given to us from B to C, it is again covering 32 meter. Okay, now total distance covered is equal to 464 meter. From O to A, distance covered 32 meter, B to C, distance covered 32 meter. That means distance covered in between AB from time T1 to time T2, it will be equal to 464 minus 32 minus 32. That will be equal to 400 meter. So this much distance is equal to 400 meter. Okay. Time O to A is 8 seconds. Let us find the time from T2 to T3. We know that area is directly given to us. Velocity is also available to us. So if we find the area of triangle BDC, area give us the displacement, which is equal to half into DC into BD. Displacement covered in this section is 32 meter. Half into BDC. DC is, let the time interval T3 minus T2 multiplied by velocity 8. 2 4s are 8. 4 8s are 32. That means T3 minus T2 is equal to 4 seconds. So 0 to T1 time is 8 seconds. This much time is equal to 4 seconds. Okay. Let us find the time T1 to T2. Again we use the area concept. Area of rectangle ABDE, it is equal to AB multiplied by BD. Displacement covered in this section is 400 meter. Time taken is T2 minus T1. Velocity is 8. So T2 minus T1 is equal to 400 over 8. 8 5 is a 40. So time taken is 50 seconds. So this much time is equal to 50 seconds. This means that one answer is available to us. Total time of the motion is equal to time of first section 8 seconds, time of second section 50 seconds, plus time of last section which is 4 seconds, which is equal to 62 seconds. Okay. Let us find the acceleration also. Acceleration in the part OA, it is equal to slope of the graph. OA, it will be equal to final velocity 8, initial velocity is 0, final time is 8, initial time is 0, 1 meter per second square. Similarly, we can find out the retardation or the deceleration. Deceleration is taking place between BC, which will again be found by the slope. In this case, final velocity is 0, initial velocity is 8, time taken in this case is 4 seconds, minus 8 by 4 minus 2 meter per second square. So retardation is equal to negative of the acceleration, which is equal to 2 meter per second square. This is our answer. There is a mistake over here. Time interval T3 minus T2 is not 4 seconds, but it is 8 seconds. So total time is sum of the time of all the three portions, which is 66 seconds, and also the final acceleration or the negative acceleration is not 2 but it is 1 meter per second square. So in this way we can solve these questions purely using the graph with the information that if it is displacement time graph, slope will give us velocity, we do not find the area. If it is velocity time graph, we can find the slope which will give us acceleration, we can find the area which will give us the displacement. If it is acceleration time graph, we do not find the slope but we find the area which give us the velocity. Thank you.